This week, we'll learn how to use a fuzzy search to find stations in MetPy's station tables. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week, I want to take a look at MetPy's station info, which we've talked about before, and then how to use a fuzzy search to help us find a station that we maybe don't quite know the identifier or the name of. So first, from metpy.io, I'm going to import station info. And the way station info works is if I know the identifier of a station, I can call the get method, much like a dictionary. And there's the information for KDIN, or Denver International Airport. So I've got the identifier, the ID, name, state, country, lat, lon, altitude, and which file that came from, which is the surfacestations.tbl file. But what if I wanted to see if there were other Denver stations, or maybe I wasn't quite sure of the town's name, but I had something close? Well, we could use a fuzzy search. As it turns out, there's a package called Fuzzy Wuzzy that lets us implement a very simple fuzzy search. You can pip install it or conda install it. And then from Fuzzy Wuzzy, import fuzz. I can get a score by calling fuzz.ratio and two strings. So for example, New York and New York. So notice there's a capitalization difference, and one is one word, one is two. That gives me a score of 80. Not too bad. So what we want to do is implement this so we can search for a town name, maybe slightly misspelled or maybe only partial, and see what stations might be candidates for being there. Now, given that we don't have hundreds of thousands of stations to deal with, we can do this in a pretty simple way and just do it all in memory. So I'm going to get the station IDs as S for S in station info. I'm going to go over that iterable and save the IDs. If we look at, say, the first 10 IDs, we'll see that, as it turns out, the first few are some metadata that we may not necessarily want to include in our search. So we're going to make IDs be equal to IDs from element 7 onward. Now if we look at the first 10 elements, we see they're all stations. So let's say that I want to search for Denver. I'm going to store my results in a list, and I'm going to do this using a list comprehension, though you may argue this is almost too complicated of a list comprehension to really use. So I'm going to say for station ID in IDs, if fuzz.ratio of station info based on, I'm going to index into that with my station ID, dot name, so I'm getting the human readable name, and my search string, that's what I want to get the score of. If that is greater than a 65, what do I want to put in my list? Remember, in a list comprehension, what we want to append goes at the front. I want to append my station info for that ID. And if I look at my results, we see that I get about a dozen results here. And there's KDIN as one of them. We also have Denver Air Route Traffic Control Center. Those are some in Texas, so that doesn't make much sense. Dexter, that's very similar to Denver. Dover. Now, of course, we could limit by state if we knew that, but this is not a bad result given just one line of code. Another way that we could do it is to store the scores for everything in our station table. Now, this might not be practical if we did have many hundreds of thousands of entries, but we don't. So I'm going to do my ratio for my search term and my station ID for for station ID and IDs. I'm going to store all those scores. You see how quickly that runs. So now if we look at scores, it's just an array. But I want to find what had the top scores. So I'm going to import NumPy as MP. I'm going to use argsort of scores. And we know that's going to sort from the smallest to the largest. We want to keep the largest scores. So I'm just going to print out for A and args minus 10 to the end. So give me the top 10 scores. I want to print the station information and the name. So my station IDs with that argument, station info, IDs, that argument, that gets me the station identifier, and then we call .name. And what do we see? Well, this doesn't quite look right. So what did we miss? Well, as it turns out up here, we need to be looking at the name attribute. So this was trying to find identifiers similar to Denver, and that turned out to not be a very easy task. But if we actually compare the name and the search as we needed to, we see that we do indeed have Denver, Denver Air Route Traffic Control Center, the TDWR, TDEN, all show up here in our list. Interestingly enough, the score for Denver was actually higher. So we could do things like make sure everything is lowercase or everything is uppercase. That would help quite a bit in making sure our scores are as close as what we think they should be as possible, because we don't care about case with town names. But this could be also very useful if you've got a ambiguous town name. So actually I'm just going to change the search right here to be a search of Springs. So we know there's lots of town with Springs in the name. And here we get Soda Springs, Iron Springs, Sand Springs, Hot Springs, Pagosa Springs, and so on. So if you know that you've got part of a town name, this is an easy way to try to find the stations that might be it. Of course, you could narrow it down more, but these kind of fuzzy searches can be really handy when you're creating a basic user interface to explore some data that you're not super familiar with. I hope that you found this useful. I'll see you on next week's MetPy Monday.